No worries. So let's first go with the architecture of the Kubernetes. Okay. So Kubernetes consists of the two main things. I think I should create a PPT in this kind of thing. I think it will be good. Okay, to understand. Okay, let's. I guess in the weekend I will try to create it. Okay.
No issues, no issues.
Okay. So let's first understand the architecture of the Kubernetes. Okay. So Kubernetes is consist of the main two parts. One is the master node and second is the worker node. Okay, so here the concept of the VMs. Okay, so is all of the VMs. And currently also there is a different thing called Docker inside Docker. So they are creating the node as a Docker container, but that is very advanced part. Okay, so you don't have to look into this right now.
Okay.
Okay. Okay, so first thing, just remember there are two main components. Okay, first thing is master node, and
Okay.
second thing is worker node. Okay,
Okay.
I will open the image here if possible. Yeah, can we? Okay, okay. First thing is master, and second is the worker node. Okay,
Okay.
now what is the architecture of the master node? What it contains? So it contains the scheduler to schedule your containers, mainly pods. Okay.
Okay.
Second thing is API server. So what is the API server? So for any application, okay. So it will need some logic, right? How to schedule, how to process it. There should be some image. Okay. So that is the
Okay.
main image here we have, which is called API server. So whatever
Okay.
you are doing currently, whatever application you are doing, it will be go through API server only. So it is a main part of the Kubernetes. Okay. Whatever
Okay.
application, like suppose you are writing any kubectl thing. Okay. Kubectl get pod. What will happen? It will go to the APIs and APIs will uh, ask the API server, get me the result of this particular API. And this API server will give you the result. Okay, so it is the main
Okay.
part of the Kubernetes. Got it now?
Got it.
Yeah. Now, next thing is etcd. So what is etcd? It is a storage for Kubernetes. What it is? Sorry, that's right. Storage for Kubernetes, but what contains? It contains all the YAML files, secret, config, all the information, whatever needed by the Kubernetes will be stored inside a etcd. Okay, so it is a,
Okay.
you can call it as a database for
Mm-hmm.
Kubernetes, which is in KV pair, key value pair.
Okay.
And so sometimes means most of the times what they will do, they will they will set up the etcd. Also, if you know about databases, for high availability, we install database cluster, right? We can create multiple nodes for high availability, right?
Right. Right.
Right. So the best practice is to have the different cluster for etcd. Okay, so best practice. It is not the component of the master nodes. Okay, but sometimes because we have like little bit budget, we install etcd on the this thing itself. Okay, master nodes. Okay, got it?
Got it.
Yeah. And next thing is the controller manager. So controller manager will handle a lot of controllers. Like there are replication controller, uh, volume controller. There are a lot of controllers are there. Okay, so all these things will be managed by the controller.
Okay.
Okay, so I'm just currently giving the brief overview. Okay, it's okay that you are not understanding every part. We are going to visit it again once again. Okay, after 1 minute
Okay.
also.
Okay.
So these are the main component of the master node.
Right.
Okay, and there is a one more thing called kubelet. What is the main purpose of the kubelet? So whatever the pods we have on the node, on that particular node, okay, on this particular node, okay, so it is a VM. Na? So all
Right.
these things will be managed by the kubelet. Okay, so
Okay.
this thing will manage. Let me see if I have the cluster. I don't have any bare metal cluster actually. But let's see, can we create it? Mm, Here they will have it. Um,
But I have a
all-
cluster ready. If you
yeah,
want.
but I guess you have created using the DigitalOcean, no? Right? DigitalOcean.
Yeah, I've created digital options. Yeah.
So if you create it within their server, so all these components means all the master nodes will be managed by them. Okay, we will not have access to the master nodes.
Okay. Okay. Okay.
So currently here, so here you can see that we have this control plane. So if you go inside here, inside this control plane, let's see the system CTL status kubelet. Oh, spelling is wrong. Okay, so can you see this thing running, right?
Right. Right.
Yeah. So it means it has the kubelet on the master node. We are currently inside a master node. Okay. And same thing you can find out this controller manager and all those things on the master nodes. So if you do ps open here grep API server. Okay, here you can see the cube API server is there. I don't remember the exact command for it. System. I don't remember exact command. I will show you tomorrow.
Okay. No issues.
Okay, so these are all the components of the master node. Okay, got it now?
Got it.
Yeah. So what is the scheduler? So main use of the scheduler is to schedule a pod on a particular node. Okay, because
Means
we will have
yeah. So means it's their responsibility on which node the
pod is should be
pod
scheduled. Okay.
should be
Yeah.
scheduled or should be
Yeah.
created. Right.
Yes, right. Should and the creation part will be done by the kubelet. Okay. One
Kubelet.
minute, I will
Okay.
just close my window. There is some sound. Okay. Yeah. So scheduler means it will just okay. So we will have like uh, node one, node two, same like node three. Okay, we will have this kind of nodes now. So like
Right. Right.
so to schedule, suppose we have created a new pod. Okay, we send some request to the Kubernetes. Okay, I want to create a new pod. Like kubectl create something, some command run my pod. Something like that.
Correct.
Okay, so it means it will send a request to API server. Okay, once you got the request to the API server, it will store the configuration into the etcd, all the YAML files whatever needed. Okay, and once that is done, it will start to create a pod, and the pod will be should be scheduled on some node, right? Node 1, 2, 3.
Right.
So there may be possibility that already some pods already present on the node one. That is why it is consuming a lot of CPU. Okay, so in that case, our scheduler will schedule on this pod on the 2 or 3. Okay, or maybe there is some possibility that need some logic on which we don't want to schedule this pod on the node 2 or 3. We want to schedule on the node one. Okay, on the specific node. So okay, so in that case, we have to add like node affinity, node and affinity, all those things. Okay, so we need some custom things. So that thing we have to specify inside a pod manifest. Once we specify that thing, what will happen? Scheduler will, according to that particular requirement, it will schedule on the particular node. Okay, according to that logic. Got it?
Got it.
So main use of the scheduler is to schedule the pod on the some node. Okay, API server. What is the responsibility of API server? API
So
server will
API server
handle.
will yeah, handle all the request, whatever like
Yes.
kubectl command we are running. So it's the responsibility to give the output, whatever the
Yeah. Yes.
request we
Process,
are doing.
all the
Correct.
requests. Yes. Right. And what is the etcd?
etcd is a configurations, right? It store all the like what you called all the
YAML
database
files.
information, YAML file and
Whatever things you are, yeah,
configuration file, right?
right, right. Whatever thing you are creating in the Kubernetes, okay, so it should be stored somewhere, na? Because
Correct.
it will not store in some file storage. it should remember it. Okay, so it will store it inside the etcd database. Okay, and it is a key value database, key value pair database. Okay,
Okay.
got it.
Got it.
And suppose if your etcd is down, then your all the data will be down, everything will be gone. You will be having the cluster, but you will not have any of your data. Like suppose you have 3 pods created, and by some mistake somebody deleted it's the cluster. Okay, then
Okay.
in that case, what will happen? All your data will be gone. Okay, so if you are giving the CK exam, then they will ask you how to backup and restore the etcd. Okay,
Okay.
so you can easily just create a backup for etcd. So by mistake somebody deleted the pod or something like that, then you can easily store it using the etcd backup and restore. Okay,
Okay.
so all the data will be stored inside a etcd. Got it, na?
Got it. Got it.
Yeah. Now, next thing is a controller manager. So there are a lot of controllers present in the Kubernetes, like to manage the pods, okay, to scale the pods deployment, handle the deployment, handle the volumes, handle the CSI driver, all those things. So this will done by the controller manager. Okay, so you don't have to worry about this thing. Okay, means you will
Okay.
not working on it on this thing, but you only need to know the purpose of this particular things.
Okay. Okay.
Okay,
Okay.
got it?
Okay. Got it. Got it.
Yeah, and next thing is kubelet. So scheduler will schedule the pod on the specific node, and the kubelet responsibility is to create that pod. Okay,
Okay.
all those things will be done by the kubelet. Got it?
Got it.
Okay, and now so this component we seen about this thing. What master node. Okay, also there is a kube proxy also. So whatever there on the worker node, same thing will be on the master as well. Okay, because we can schedule the pod on the master node as well, but it is not recommended to schedule any pod on the master. Okay.
Okay.
So now let's see the specific component required for a worker node. First thing is kubelet. As you have already seen, what is kubelet? So kubelet is to handle the pods. Okay, to create a pod, handle the pod, it will be done by the kubelet. Okay, on that particular node. Got it
Okay.
now?
Got it. Got it.
Next thing, we will require container runtime. Okay. Interface. Okay, so currently means in the image we are seeing Docker. Okay, Docker Shim, but now it is a container D.
Okay.
Okay, so what happens from the Docker 1.21? Docker is not supported in the Kubernetes. They have removed Docker. Why? Because Docker internally uses the container D. Okay, so it was the extra layer. So because of that, in the Kubernetes code, they have to maintain some code to make it work with the Docker. Okay, but in the new versions of the Kubernetes, like from 1.21 onwards, they have removed support for the Docker. Now they are using
Okay.
the container D for
Okay.
spinning up our images. Okay, so it is a CRI. CRI means container runtime interface.
Okay.
It is a Docker. Okay, next thing is the kubeproxy. Okay, now suppose we have like multiple nodes, 1, 2, 3, 4, 5. Okay, and they want to
But
communicate.
yeah, but I'm not able to see your screen. I think it's freezed on somewhere. Can you reshare?
Can you see
Yes. Yes. Yes.
architecture?
Now. Yes. Now I'm able to see. Hello.
Yeah,
Yeah.
can you see this image?
Yes. Yes. Now I'm able to see now.
Okay, now next thing is about the kubeproxy. Okay, now what is the user kubeproxy? So kubeproxy will handle the IP tables on each node. Okay, so these components are the separate for each and every node. Okay, so understand this thing means every node will have the kubelet, their own kubelet, their own CRI, their own kube proxy. Okay,
Okay.
you're getting no? The
Yes,
things
yes, yes.
separate for each and every node. Okay, so
Right.
kubelet responsibility is to handle the container of that node only. Okay, that
Okay.
node only. Okay, now we will use yeah, here kube proxy. So what is use of kube proxy? Kube proxy will handle the IP table on the each node. Okay, because there will be changing of the IP. Like each pod will have the separate IP, right? So
Right.
how do we know? Okay, which pod has the which IP? Okay, so kube proxy will help us in that thing. Okay, they will maintain the IP table on each node. Okay, so suppose someone is hitting, okay, they want to get some Nginx pod, okay, or some application like my product, I want to access my product service. Okay, so this thing, so there is a component called service in the Kubernetes. Okay, so the request will go to the product service, and that thing, then again, after that, the product service will point out to the node, okay, on which node that particular service is there. Okay, and then the request will go to that node, and once that is go to the node in the kube proxy table, they will search, okay, what is the IP of that particular pod which is serving this product service. Okay, okay,
Okay.
so it will maintain the IP table. Got it, no?
Got it. Got it.
Yeah. So this is the basic architecture. Can we? Why I'm not able to zoom it out? Okay. So there is the same thing. Same thing can be seen in another diagram as well. Okay. If you see here, it is a master node. It contains the controller, and there is a core of everything is the API server, and then there is a scheduler which will schedule the pod on the nodes, and there is a QL store which is a etcd. Okay, then again there are multiple nodes available. Okay, multiple worker nodes. So this is the architecture of the master node. Now there is another thing called the worker nodes on which all our pod will be running. Okay, we can run the pod on the master as well, but it is not recommended to run on the master. Okay, and on the EKS it is not also possible to run on the master node. Okay, on the EKS. Okay, so you don't have to worry. Okay, and the node contains the these things: Docker container, kubelet, kube proxy. Got it, no?
Got it. Got it.
Yeah, the same architecture. Yeah. Now there is a one more thing called a plugin. Okay, plugin like Flannel. There is a plugin called Flannel. I just let me search Kubernetes networking plugins, because to get a IP to your pod, okay, we need something. Okay, it is called container network interface. So we have to install this thing on your machines.
Again, it I think is freezed. I'm not able to see that.
Oh, I don't know what is the issue today. Can you see what you are seeing?
Yes. Yes. Yes.
If
Yes.
you, so if you go here on the internet and search for networking plugins, so there are a lot of plugins available. Mostly they are Flannel, ViewNet, and what was that? I don't remember the every plugin name. Okay,
Yes.
but if you are going with EKS, you don't have to worry about this thing. Okay, which plugin you have to install. Okay, but
Okay.
what is the CNI? So CNI is an interface for networking of this particular pods. Okay, because suppose we are creating a containers. Okay, they need to communicate with each other, right? How
Right.
they are going to communicate? For that they will need some IP, right? Some
Right.
interface,
Right.
some network gateway. Okay, all these things will be done by some plugin. Okay, so we have to install that particular plugin. Let me see. I have any plugin, if not. Clip system. Um, uh, Kube proxy. Here you can see if you do the kubectl get per kube system, you can see the kube proxy on each and every node. So it is currently running as a daemon set. Okay, daemon set we will search for learning next thing. Okay, on the Kubernetes they are not on the EKS they are not showing this thing. Okay, but if you install on the bare metal, na, you can see. Yes. Canal and Calico. Okay. So Calico is there, Flannel is there. Okay. So these are the popular networking plugins. Calico. Okay. See my screen, na?
Yes, yes.
Yeah. So there are popular plugins like Calico and the Flannel. You can search on the how to install a Kubernetes using KubeADM. Okay, just search this thing. Then there is already a process. There's already architect articles how to install it. Okay, so we currently use the KubeADM. So there are various way. If you go with like if you want to install it from everything from scratch, okay, without using KubeADM, so it will take you 2 weeks. Okay, so there is a tool called KubeADM or some binary called KubeADM, which will do all the parts like creating a certificate for all your master nodes, because everything should be encrypted. Whatever data is it flowing from the master node to worker node between the worker node, everything should be in encrypted manner. Okay. So for that, we each and every component will require their own certificates. Okay, so that is very lengthy process. Okay, and you don't want to work on that. So that is why you can use the KubeADM tool. Okay, so it is the simplest way to create a Kubernetes cluster.
Correct.
Okay. So here you can see the installer CRI runtime on all nodes. So it is a container, the container D. And then once you install this thing, then use install the kubelet, KubeADM, kubelet, and kubectl. And what is the kubectl? Kubectl is just a binary which can help us to uh, interact with the kube API server. Okay, so we can install kubectl anywhere. And suppose if you have some kube config file which has the credentials for your Kubernetes cluster, then we can easily talk with your Kubernetes cluster. Okay, so kubectl is not part of your cluster. Got it, na?
Got it.
So this thing is different and this thing is different. Kubelet is to handle the pods, and kubectl is different thing. We just run our command using kubectl, which will talk with the kube API server, right?
Right.
So just understand this different. And kubeadm is a tool to install your cluster. Okay, so first of all, you have to install the kubeadm. Once you install the kubeadm, then you have to install the kubelet and kubectl and then docker, all those things. And then there is a command for the kubeadm to install a cluster. Okay, let's see what is the command.
Okay.
Here, sudo. So on the master node, you have to run this thing, sudo kubeadm init API server address. Okay, suppose if you want to give any static address, then you can pass it. And then there is a pod CIDR. Okay, so whatever the IP will be given to the pod, it will be from this particular pod CIDR. And the main use of this thing, suppose if you have like multiple master nodes, so in that case you can have some load balancer, and then you can give the load balancer address here. So that is very advanced part. We are not going to go that in this particular things. Okay, because our main focus only is to run the learn what is Kubernetes in the development part, how to create pods and these things. not to focus on how the other things work.
Correct.
Okay. Okay, so this is the command using which on the master node you have to run this thing. Then it will install the necessary packages. Okay, some extra things. Once that is done, they will give you some command like kubectl join. Okay, so this kubeadium join. So this command you have to run on your worker node. Okay, once you run this thing on the worker node, hello,
Hello.
hello, yes. So once we run this thing on the worker node, na, hello, hello,
Yes, yes, I'm audible.
yeah. So we have to run this particular command on your worker node.
Okay.
So same thing we have to install on your worker node. You have to install the kubelet and the kubeadium. Okay, that's it, and Docker or
Okay.
any CRI like containerd. And once that is installed, that's it. The your cluster is ready. So there are also more steps are there. We are going to see it on the Monday.
Okay.
Okay, how to install the means create a cluster. Okay, that we don't have to do. And then there is a next part. Install
Okay.
Calico network plugin. So if you don't
Okay.
install this thing, na, so then your pod cannot communicate with the other pod. Okay.
Okay. Okay.
Even your node cannot communicate with other pods.
Okay.
Okay, so we have to install these plugins. Okay, so I just said there are multiple plugins available. So CNI is a interface which and other plugins are using this interface. Interface means it is kind of a practice. Okay, what should we
Yeah.
do to create a plugin? Okay, so it is
Okay.
an interface when anyone can implement it. There, the CNCF Foundation just given us the some how what you can say some model. Okay, you have to follow this model. Okay, if you want to create a plugin, you have to follow this model. Okay, got it, na?
Got it.
Yeah. So same things are followed by this Calico plugin and that panel plugin and the viewer plugin. You can install any of the plugins depending upon your own requirement. Okay, that's it. So it, this is the command which is used to install the plugins. Okay,
Okay.
and can you
Okay.
see here Calico Kube Control, Calico Node, these things?
Right. 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 Right.
Okay, so once you install this thing, na, you can see. Okay, so all these things are the Kubernetes manifest. Okay, these things.
Correct.
Once you install these things, then you can communicate with other pods and nodes. Okay, that is use of the CNI plugin. Got it, na?
Got it. Got it. Got it.
Yeah, once that is done, your cluster is up and ready. Okay, so that is about the Kubernetes architecture. So do you have any doubts?
No, as of now. So we will manually also create, right?
Oh yeah. Means on the Monday, I guess tomorrow we'll take some holiday and on the weekend also.
Okay. No issues.
Okay. Maybe if possible, if I get time, I will try to create some documentation for this particular
Okay.
architecture.
Okay. No issues. No issues.
So it will be easier for you to follow. Okay, what is
Okay.
purpose of this particular thing?
Correct. Correct.
Okay.
Correct. Correct.
But you got it all the architecture right now.
Right. 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 Right.
So please, so can you explain me Kubernetes architecture means what do you got?
Okay, so what I've understood it, first of all, if in a master we have a API server, API for server responsibility is like to handle all the command, whatever the instructions are we are giving to the cluster, that it is API responsibility to perform and provide output, correct? And now the scheduler responsibility are to deploy a pod on the node, the worker nodes, correct?
Right, exactly. Yes.
And then we have a cube what you the that third one was the that responsibility to create the that was the
Kubelet.
kubelet, sorry, kubelet responsibility was to just to provide a to create that particular node on the worker nodes. Correct?
Yes, to
Correct.
create a pods on the
Particular
nodes.
nodes, and etcd responsibility, it create all the configuration related informations,
It,
right?
it it will not create it, it will just store it. Okay,
Is store
whatever
it, and
thing.
if you want to take a backup and something, so you have to take the backup of etcd, so that if you will just copy and paste it again, so it will create a complete cluster. It have a complete information of the cluster and configurations, right? It also could create contain the YAML file, correct? That
Right. Means
configuration
yes,
file,
not
correct?
YAML file. Whatever
Yeah.
things you have written in the YAML file, it will store
Yes.
inside etcd but with the other
etcd.
format. Yes. But for
Yeah.
understanding, I'm just saying that it is a YAML, but it is
Yes,
actually
yes,
not
yes.
YAML.
Yeah. Manifest. So kubeproxy, it's contain the information about the IP address of the port, correct?
Yes, it is manage the uh, what you can say.
Mm,
It manages the IP table on the nodes.
IP tables, sorry, IP tables on the nodes, correct? Hope I'm
Yes.
understood correctly, right? All the things.
Yes, right. And what is the kubelet? Sorry, kubectl.
kubectl is a command through which we just perform all the actions, right?
Yes, right, exactly. And whatever you're typing, it will go through the API server.
API server, right?
Yeah. So this is about the master and worker node architecture. And also there is another thing called HF architecture, which means high availability. In that
Yes.
case, what happens? We'll have multiple masters. Currently, here we are seeing only one master, na? But in that
Right,
case,
right.
we have that multiple master like 3, 4, 5, 7. So there is a
Correct.
thing called quorum. Okay, quorum means we have to create a master node in the particular number like 1, 3, 7,
Correct.
9. So there is some formula like n plus 1 divided by 2 minus 1, something like that. Right now, do you know about this?
No. I'm not about.
Okay, so some formula is like this, minus 1. So if you put like 1 here, let's say 1. 1 plus 1 is 2. 2 divided by 2, yes, it is 0. Right. If you put 2 here, 2 plus 1, 3. 3 by 2 is still 1. 1 minus 1. It's still, I guess, 2. Minus 1 is here. I don't. Right, let's search on internet. There is some formula called quorum tool. What is quorum? Yeah, quorum formula. Quorum. Are they giving any? Okay, so there is a no. Okay, they are not giving it here, but there is some rule. Okay, so you have to create a master node in this manner: 1, 3, 7, 9. Okay, if you want to go with like only one master, okay, that is okay. If you want to go with more than one, then you have to create a 3 nodes, not a 2 nodes. Okay, why?
Right,
Because suppose your second node also went down, then you have zero thing, na?
right.
Right. So because of that, they have three things. Okay, so that is a formula. Uh, yes, and in that case, what happens? They will create some load balancer because we cannot hit. We don't need to know the IP of the each and every node. Suppose we have seven master nodes. Okay, so how do you know what is the IP of? Means you cannot store it somewhere. Okay, the 7 node
Right.
IP. Okay, in that case, what we will do? We will create a load balancer. Okay,
Okay.
and in that load balancer, in the backend config, we will configure all our nodes.
Okay.
Okay, and suppose if you want to now access the Kubernetes, okay, in that case we'll hit to the that load balancer IP. So that it means for our case it means we are accessing the Kube API server. Okay, but in the backend what we are doing, we are accessing the rest of the nodes. What I'm saying, just let me demonstrate. Like Like suppose we have 7 nodes, master nodes. Okay, master node 1, 2, or let's go with the 5. Okay. Suppose we have 5 nodes. Okay, so each time, suppose if you want to access some node, now suppose this node failed. Okay, then suppose in some node we have configured this particular node IP, so it is then it is useless now because this went down, but
Correct.
other 4 are available. Okay, so instead of giving hard coding any node IP, what we will do, we will create a load balancer, like again for some HA proxy load balancer, something like that. Okay, in
Okay.
that case, what we will do, it will have some IP like public IP 1, 2, 3, 4. Okay, and here in the backend config, we will mention this node IP. This
Okay.
one
Okay.
IPs. Okay, like 10.10.0.1, same thing like here. 3, 4, 7. Okay, and what we will do in the kube, our kube config, we will mention this IP. Okay, so suppose our kubectl now is accessing this particular IP. What in the backend, it will try to hit one of the master server. Okay, so in that case, we don't have to mention hardcode any of this IP. Suppose in because of some issue, these 2 nodes went down. So no issues because this is the HTTP proxy. It will query these nodes after certain intervals, and if these nodes are not sending the health checks, it means they went down. So it will not send a request to this particular node. It will send to the all the positive alive nodes. Okay,
Okay.
what I'm saying?
Got it. Got it. Got it.
Okay, so this is about the master and worker node. Maybe they will ask you in the interview, some interviews, not now, maybe in future. Okay, just
Yeah. Now I do not want to give any interview, but I just want.
yes, yes. Just for your knowledge, I guess it is
Yes.
easy.
Yes. 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 Yeah.
Okay, so this is about the architecture of the Kubernetes.
Yeah.
Okay, now this is about the Kubernetes architecture. Next thing we are going to learn about the Kubernetes resources. Okay, so
Okay.
like we now the architecture is the next thing. Okay, we already understand what is architecture. It contains the master worker nodes. Okay, and inside that master node and the worker nodes, they consist different components. Okay, now
Right.
this thing is about the Kubernetes. Okay, now we are going to learn about the what things we are going to create using Kubernetes. Okay, so there are different kinds like pod, deployment, then volumes, config map, and secrets, all those things. Okay, so these are all the kinds. Kinds means it is some kind of type which is supported by the Kubernetes. Okay, let me show you
Okay.
some of the pods. Yes. So now if I do kubectl get pods. So K is just alias. Do you know what is the alias?
No.
So yeah, K means kubectl. Okay, so kubectl K means same here because I have just rename this kubectl command to the K. Okay, so maybe you get you may be got confused. What is this K pod? K get pod? It is same as the kubectl. Okay, if you type kubectl, it is same as the K. Why? Because we have added alias. If you see the alias here, K is equal to
Yes. Yes.
kubectl.
Yes. 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 Yes.
Now if I give the kg kubectl get, if I do the kubectl get pod, here you can see that now kubectl get is equal to kg. Okay. Now if I now this is our cluster. If you install a cluster, now go inside it, just do kubectl get nodes. So it will show how many nodes are there. Okay. So currently we have 2 nodes. One of them is the control plane, which is master node, and another one is the worker. Okay, how do identify that it is the master node? Just do kubectl describe node and just this thing. give all the properties of this particular node, and maybe in somewhere they mention it is master or not. So let me describe the control plane. Yeah. So host and host. There was some way, I don't remember it, but some date or something they will add it. Using it can identify it is master node or not. Verify intent. Okay, yes, using this thing, this identity, we can identify it as a what master or worker. Okay, got it this part now. I
Right,
think
got it.
it is enough for today.
Yes, I think, yeah, it's enough.
Yeah.
I will
So
go through it and I will see some video as well. So related
yes,
to
yes.
that.
So it will be useful. Okay.
Yes, yes. I have
Okay.
enough
We'll
time
do.
to go through. Yes.
Okay.
So
We'll
we
meet
will
on
meet on
Monday.
Monday morning or evening?
On Monday at 11. No, I have.
No issues. Monday we will meet same time and
Yeah,
we will decide later, right?
yes, yes. We'll decide later.
Okay, okay.
Maybe next week. Maybe I'm not available. Not sure. Maybe next.
Okay, you just ping me whatever you
Okay.
understand.
No, no, but just join the call. Okay. If I ping, okay. If I'm not available, then I will just ping on the group. Okay.
Sure, sure, sure. Ping me. No issues, no issues. All right.
Okay. 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 Just
Okay.
do the practice also of the Jenkins also. Okay. On
Sure,
your
sure,
weekend.
sure. I will try. I will try my best.
Okay. Okay. Bye.
Okay, sir. Thank you.